Next, Paul will tell us about how we might use modularity to help accelerate the development of anti-censorship tools. So as soon as you're ready, go ahead.
All right.
It's not
Yep.
showing yet. There you go.
Okay. Yeah, so I'm Paul Vines from 26 Technologies, and I'm here to talk about my paper, Communication Breakdown, aka the Raceboat paper, which will hopefully stop flickering at some point. Try another slide.
It stopped flickering.
Yeah, it did stop flickering. Okay, we'll go with this. Do you want me to run it up there? Yeah. So I guess while that's getting started, so Raceboat is a framework. So it's not a specific channel like OBS or Snowflake, but it's a framework more along the lines of pluggable transports that provides an interface for, on the top side, for applications like Tor or Siphon, or pick your application that wants to use special channels to circumvent censorship. Provides an application interface on one side, and then it provides a channel interface on the other side. So that's for interacting with something like OBS or Snowflake or something else. So in that way, it's very similar to pluggable transports. But it is, from the application standpoint, it's sort of has some more nuance. It has more interaction modes than pluggable transports. And from the channel perspective, it has a cool thing, which I'm not going to talk a whole lot about in this talk, but if you look at the bottom right there, we have this decomposed channel framework, which lets you sort of build individual components of your channel, rather than having to build an entire channel, which can hopefully let you, as a channel developer, sort of do more cool research and rebuild the same old wheel fewer times. So that's roughly the order of the talk. We're going to talk about the application interface first, and then we're going to briefly talk and walk through a demo, and then we're going to briefly talk about the decomposing approach at the end. So our motivating example, as usual, we have a censored user in a censored network, and they want to go out to the open internet to do things. So think your censored Tor user example. So typically, right now, this is going to involve reaching out to a bridge distributor via what we're calling a signaling connection, and getting information about a new bridge that hasn't been blocked yet, and then making a connection to that bridge to do your actual browsing or whatever it is you wanted to do on the open internet. And both of these connections need to avoid being blocked or detected and blocked. And so they're going to need to use sort of weird network channels. And Raceboat can provide one or both of these connections and even bundle them together, which is the demo we'll walk through. So briefly on signaling connections, so this is the main pitch of the paper, is that Raceboat would be good for doing this. So the idea here is this is for contacting a bridge distributor or other sort of relatively high latency, low bandwidth methods. Somewhere between 1 to 4 messages is what we're expecting, and sort of not terribly huge. And the important part about a signaling channel is that it needs to have no shared secrets, right? So you need to remain unblocked even if the adversary knows all the same information the client does. So you can build it into code or publicly broadcast it in some manner and not have it get blocked. So domain fronting would be an example. So to talk about the application API in a little bit more detail, we've got 4 modes. So the first one is just a unidirectional push. This could be used for things like telematics or software updates, depending on which direction you want to go. We've got a receive, respond, or request respond mode. So this pretty much matches with the bridge distribution case, where you've got one message going one way and one coming back the other. And then we've also got 2 socket modes. So the socket mode here is just your standard, one upstream, one downstream link. And the demo I'm about to show will have a bootstrapping socket, which is somewhat like Snowflake in the sense that you're going to have an initial pair of links that facilitate bootstrapping another link. The things I want to note, so these different colors here mean these can be completely different channels. And so that's one of the sort of core strengths of Raceboat is the idea that you can sort of compose channels together and use them interchangeably. And so any of these links can be different channels, and we're trying to sort of systematize building channels and using them more elegantly. So from a sort of higher level perspective, as I said, Raceboat is about channel composition. So pluggable transports lets you swap individual channels without changing your application code, pretty much. Raceboat is about trying to abstract it up to the sort of connection level and let your application potentially use multiple channels simultaneously without having to do any sort of intelligence at the application or changes at the application layer. So you can mix and match channels, as we're about to see. You can, I think this could potentially let you adapt to sort of specific adversaries and specific user circumstances more easily by just changing configurations instead of needing to rebuild and expand your application code. And I think this really provides a good method for being able to use unidirectional channels and low bandwidth channels, which can have very nice security properties like this public addressability, but can be very difficult to use for actual applications. All right, so this is the demo that's been sliced into screenshots because I can't pause the video. So what we're going to do over here on the left, the right, we want to end up with the bottom blue and purple as a bidirectional connection. So we're going to be using obfs one way at the end. We're going to pretend obfs is unidirectional just for sake of demonstration. And we're going to use a different channel, a simple TCP socket going the other way. And we're going to bootstrap those links from publicly addressable information, specifically the skyhook links, which I talked about at Foci a couple days ago, which uses Amazon S3 buckets to provide that. And you could imagine something like domain fronting or other signaling channels could be used there. So we're going to start out, the server, which is the black terminal, is going to start running Raceboat, and it's going to specify a skyhook link. So this is the public information that the adversary can also know without disrupting the link. So it's going to create that in the purple box, and then it's going to share it out of band to the client. And then the client is going to load that information, and it's going to create its side of a private skyhook link, which allows it to receive information from the server, and also create its side of an obfs link. So it's being an obfs server in this case. And the top right is a Wireshark terminal showing packets color-coded by which link is being used. So in this case, we've sent something over S3 because the client is sending its hello. So it's going to package up information about those 2 purple links and add it to a hello message that it's going to send to the server on the green public skyhook link. So now the server has received this information. So it's received information about the private skyhook link and the obfs sending link. So it's going to load those based on that information. And you can see it's loaded the obfs link by the purple traffic, which is obfs doing a handshake. And it's also going to create its side of the last link, which is the simple TCP link for client to server. And so now, this is the last step of the handshake. The client is going to, this information is then going to be sent over that private skyhook link, specifically the purple TCP information. It's basically the hostname and port of the server. It's going to be sent over the private skyhook link. So now the client receives that and is going to load up its side of the simple TCP socket. And so at this point, now we've got these 2 bottom links. The skyhook links get torn down, and we've got our sort of 2 unidirectional links that are acting as a abstracted bidirectional connection as far as the application is concerned. And so for our simple demonstration purposes, we've got basically a netcat client and server running. So our client has sent some data to the server. We can see the blue traffic because we're using the simple TCP link, which, unfortunately, I messed up the color coding there. But the purple link corresponds to the blue traffic. And then the server can reply, and it replies on obfs, so we see a bunch of purple traffic. So that's that's the demo. There's a video version, but as I said, I can't step through that. So now we're going to switch to the second half of the talk, which is going to be very brief, just motivating, really. So decomposing channels. So we had this was all built as part of a program where there were a bunch of different teams building new anti-censorship channels. And for the most part, they each basically had like one really great idea that they were building into their new channel. And then they had to build the rest of the channel too, which involved a lot of sort of rebuilding, kind of the same, nothing super novel, but it had to be built in order to make the channel work. And then when they finished doing that, we got 4 channels that each had one really cool idea and then other kind of existing art stuff. And we couldn't combine all the good ideas or all the new ideas because they were each sort of monolithic, unified channels. So we built this decomposed application tunneling framework where the idea is you can build only one of these 3 components, whichever your great idea falls into, and then you can reuse other people's code for the other ones. So the breakdown is you've got a user model that controls sort of interacting with a service, trying to look like a realistic user, not hitting rate limits, that kind of thing. Then you've got a transport that handles like actually interacting with APIs and the application. And then you've got encoding that handles creating content. Often this could be steganography, but any other sort of content manipulation that needs to be done. The idea is you can swap these out as long as they're API compliant. You can swap them out with each other and get a lot of reuse. So in conclusion, on the application side, Raceboat can provide more different functionalities and let you mix and match channels simultaneously, which Pluggable Transports doesn't let you do, so it might be interesting there. On the channel side, hopefully lets you sort of write less code and get things built faster and have greater impact. And then my last point is, and I think I've seen this in the Foci papers, which is nice, we don't need to evaluate every signaling channel by pretending it's a good main socket transport and trying to browse Tor and seeing how long it takes me to fetch a page. With that, that's the talk. And if anyone's interested, I'm very happy to talk to people about this. I'd really like to try and get it being used somewhere. So
let's thank the speaker. We have time for a question. We're running a little late, but we have time for a question. Piyush, down in the front.
Hi, thank you for the nice talk. So if I am a developer of, let's say, a transport channel, how easy do you think is the integration process in Raceboat in comparison to, let's say, what we already have in pluggable transports? I do know they have this, inter-process communication API. So is it like that is also involved in the Raceboat integration process, or it simplifies it somehow?
So I think it can simplify it, I think. If you were going to sort of copy the pluggable transport Golang module, you wouldn't have to do quite that sort of copy here. Other than that, I wouldn't say it's immensely simpler. The main gain is if you can componentize it, then you can potentially reuse other people's other modules. So if you have a new Stego algorithm, you don't have to build the, let me post it to a random website code. You can use somebody else's, everybody else's.
Okay, I'm a pluggable transport developer. Have you thought about how to quantify the amount of effort required to write my pluggable transport in the language that I choose with the tools I'm familiar with versus me writing it to fit in the Raceboat framework?
I'm not a software engineering researcher, so I do not know how to quantify that. I assume it is more effort to get started because it is similar but different APIs. But
I need some sexy data to tell me, oh, you should definitely do it this way, not the other way.
If you get me a list of pluggable transport developers, we can try and do a user study.
Okay. Let's thank the speaker again.